The universe is vast and mysterious. It's filled with billions of galaxies, each containing billions of stars. But how did it all begin? The most widely accepted explanation is the Big Bang theory. This theory suggests that the universe started from an extremely hot and dense state about 13.8 billion years ago. Imagine a tiny point, smaller than an atom, containing all the matter and energy of the universe. Suddenly, this point began to expand rapidly. This expansion, the Big Bang, marked the beginning of space and time as we know it. In the first fractions of a second, the universe cooled and expanded at an incredible rate.
As the universe expanded and cooled, energy converted into particles. These particles eventually formed the building blocks of everything we see today: stars, planets, and even us. The Big Bang theory is supported by a lot of scientific evidence. This includes the observation of cosmic microwave background radiation. The Big Bang theory is a remarkable achievement of modern science. It provides our best explanation for the origin of the universe. However, it also raises profound questions. What existed before the Big Bang? What caused it to happen? These are questions that continue to fascinate and challenge scientists today.
The Big Bang was just the beginning of the story. The early universe was a chaotic place filled with hot gas and radiation. How did this chaotic soup evolve into the structured universe we observe today? The answer lies in the fascinating process of cosmic evolution. Gravity played a crucial role in shaping the universe. Over millions of years, gravity pulled together clouds of hydrogen and helium gas. These clouds became denser and hotter, eventually igniting nuclear fusion and giving birth to the first stars. These early stars were massive and short-lived, but they produced the first heavy elements like carbon, oxygen, and iron.
As stars died, they exploded in supernovae, scattering these heavy elements throughout space. These elements became the building blocks for new generations of stars and planetary systems. Gravity continued to shape the universe, pulling together stars to form galaxies. Galaxies collided and merged, creating even larger structures like galaxy clusters and superclusters. Cosmic evolution is a continuous process. Even today, new stars are being born and galaxies are colliding and merging. By studying the universe around us, we can piece together the history of its evolution and gain a deeper understanding of our place in the cosmos.
The emergence of life on Earth is one of the most profound mysteries in science. While we have a good understanding of how the universe evolved from the Big Bang to the formation of planets, the origin of life itself remains an enigma. This process, known as abiogenesis, refers to the transition from non-living matter to living organisms. Scientists hypothesize that early Earth was a very different place than it is today. The atmosphere was likely composed of gases like methane, ammonia, and carbon dioxide, and the oceans were hot and acidic. Despite these harsh conditions, life somehow emerged.
The prevailing theory is that life arose from non-living matter through a series of chemical reactions. These reactions would have been driven by energy sources like lightning, volcanic activity, or ultraviolet radiation from the sun. Over time, these simple molecules self-assembled into more complex structures, eventually forming the building blocks of life such as proteins and nucleic acids. While we have not yet recreated abiogenesis in the laboratory, scientists are making progress in understanding the chemical pathways that might have led to life. The discovery of extremophiles, organisms that thrive in extreme environments, suggests that life is more resilient and adaptable than we once thought.
The question of how the world began has captivated humanity for millennia. Science offers compelling explanations through the Big Bang theory, cosmic evolution, and abiogenesis. These theories are supported by a wealth of observational evidence and provide a framework for understanding the natural world. However, science is not the only lens through which we view the cosmos. Religion and philosophy also provide profound insights into the origin of the universe and our place within it.
Many religions offer creation myths that explain the world's origin through the actions of divine beings. For example, Abrahamic faiths describe God's creation of the universe in 7 days, while Hindu cosmology speaks of cyclical universes being created and destroyed over vast periods. These myths reflect the human desire to find meaning and purpose in the universe.
Philosophical arguments, like the cosmological argument and the anthropic principle, grapple with the existence of the universe and our place within it. The cosmological argument suggests that the universe must have a cause, which is often attributed to a divine creator. The anthropic principle observes that the universe's fundamental constants are finely tuned for life, suggesting that our existence may be more than just a coincidence.
While science, religion, and philosophy offer different perspectives, they are not mutually exclusive. They represent different ways of exploring the profound questions surrounding our existence. As we continue to probe the mysteries of the universe, we can appreciate the diverse approaches that humanity has taken to understand our place in the cosmos. The search for answers about our origins is an ongoing journey, one that continues to inspire awe and